Hello. I would like today to explain you how to read a meter, which is very important, and that is an observation, and then we'll move on with forecast. So now, this is our meteorological terminal report. That is our internet, our airdrome code. That is France, and that is the name of the airdrome which you are. You should type that in on your computer, your browsing research, and then it's the time at which was edited the meter. It is meaning that 8 UTC, Z meaning Zulu time, UTC time, Universal Coordinated Time, and that is Greenwich time. So if you make the difference with Paris, it's 1 hour. So here is 9 o'clock. Okay. Automatic meaning it's done by computer, and then the wind is southwest today, 220 degrees, 11 knots. Still in visibility okay, meaning that there's no clouds under 5,000, 10 kilometers visibility forward, and then there is no clouds and no cumulonimbus, no precipitation. Then the temperature is 9 degrees Celsius and the dew point is 0.8 Celsius degree, and that meaning that the volume of air is saturated at this temperature, meaning that will create clouds, condensate and create clouds and precipitation eventually. Tempo fluctuation, that is 220, 20 knots and gust of 35 knots. Ending of our message. This is our observation, is what is happening now eventually, and this is a forecast. Terminal air forecast stuff, meaning terminal air airdrome forecast, and it's a short one. We have long, tough, and short forecast, and the short one is 9 hour length and will be edited every 3 hours. And this one was edited at 8 o'clock, 9 o'clock, at 12. There will be a new one, and the wind is 240 degrees, 15 knots Quebec, sorry, 50 knots, and then gust 25 knots. So slightly different with our observation, and then our visibility, frontal visibilities mean that we have 10 kilometers visibility in front of us, different from Quebec. Quebec gives much information, meaning that we have a situation in which we have no clouds, we have no rain, no precipitation, and we have 10 kilometer visibility. Instead here, we have just 10 kilometer visibility. Broken 3,000 above ground level, meaning that we have almost a ceiling at 3,000, and tempo fluctuation from 10 to 6, so from 11 to 7, the wind will be 220 20 knots and 35 gusts. Reduction of visibility to 4,000, shower rain broken, 2,000 scattered, 2,500 with cumulonimbus, meaning kind of clouds which are very dangerous. We won't be close to this kind of clouds, neither under, neither inside, especially not inside, no close at all, because it gives a lot of instability, rain, precipitation, all kind of electrical activity. They have a vertical extension very high, probably from 200 and 2,500 to more than 20, 30,000 feet above ground. And then probability 30%, tempo from 1 o'clock to 4 o'clock. We will have wind 230 degrees, 25 knots, 45 gust of 45 knots. Okay, ending of the message. So this is how to read, how to decode a METAR and a TAF, and that's something that's very important for a pilot before starting a navigation. Always read your note time and your weather information of your airdrome and the airdrome where are you going, and on the way you always have to respect your flight plan. This VFR flight or EFR flight, you always have to be you always have to respect the regulations on the limits of the kind of flight you are doing. Then I will start with the short briefing today. Today I will explain you, try to, always if you have suggestion, correction, please. I'm here to listen your comments, transition, slow transition, and rapid or quick transition and quick stop. Our objective is overtaxing safely and be able to reduce our speed or increase our speed and quick stop and reduce our speed. So these are all the maneuver that I will explain during this short briefing. Review of what is important to know before starting this briefing is the power that we have that can develop the machine, and diagram HV. This diagram HV, high and velocity diagram, is very important. You should be familiar. It's inside your pilot handbook, and you should always be familiar with this kind of diagram before starting overtaxing of maneuvering your helicopters. This is our HV diagram, as you see. You won't find yourself in this area or in this area, okay? You always were over taxi. You try to avoid to be at a certain speed and a certain high, which make you to be in this kind of situation or this kind of situation, and that you won't be, if you have a engine failure, you won't be able to safely land. So you want to avoid really this kind of areas. This is not a diagram that you should be familiar with, and they explain you the maximum continuous power that the helicopter can develop during the day here. And this is the power necessary for each kind of maneuver you are operating. In this case, this is rate of best climb, the velocity of rate of best climb. So you have certain velocity which is indicated in your pilot handbook that suggests which kind of velocity is the best rate of climb. And this is the best cruising speed. It requires a certain amount of power. This is necessary power, and this is the maximum speed. And this is the power required for outside ground effect, and this power required for inside ground effect. So you should be familiar also with this diagram. And now we start with our transition, slow transition. And you can see this is our helicopter. You see here, this is our cyclic. We are in ground effect. You put your cyclic forward. You keep your pedal. You try to manage to keep your slip indicator, the ball on the center. So the helicopter is axed with the taxiway, and your objective is to go from this point to this point. That is, for instance, the iPad. And what you do, you increase your speed. By increasing your speed, you have the effective of transitional lift, which change the situation of turbulence of the air in relation with your rotor disc. In fact, as you can see from this picture on my left of the screen, down on the left of the screen, you see there are two helicopters. The one that is higher of the other is in hovering state, and you see that there is a certain turbulence of the air creates vortex around the blades, which reduce the lift of the helicopter. In fact, when you are operating for hovering, you always have to raise a little bit your collective a little bit more. Instead, when you increase your speed, the air enters the rotor disc differently. As such, the lift is increased, so you need less collective in order to have the same lift. You see in this picture, the one lower, the one that is under the other helicopters, you see the air is entering almost in a diagonal way from in relation with the rotor disc, and is axing and freeing the helicopters from the turbulence of this air. This is very important. That's why we have more lift when we go forward. Then now, as you can see from my drawing here, you can see from my PowerPoint, you are a little bit climbing because you are increasing your speed, but always remember to keep your high no more than 2 meters from the ground 7, because you want to stay in ground effect, and you will use your collective in order to manage this distance from the ground, and always keep your nose of the helicopter actioned with the taxiway. So check your slip indicator, and you, of course, you will have a speed of 20 or 30. Then at a distance that is third from your helipad, you decide to reduce your speed. What you do, you put your cyclic backward, you lower your collective, and you put right foot. We have talked about why. It's this primary and secondary effect of the flight controls, and eventually the speed will reduce. And then what happened that in order not to have your nose pitch up, you will put a little bit cyclic forward, keeping your helicopters with no slip, and of course by reducing your speed you are losing the effective of transitional lift. So the helicopter will descend, and then you will raise a little bit your collective, putting your left foot to keep the helicopter not touching the ground. So stay in ground effect but not touching the ground. So stopping eventually on the helipad your helicopters. What is important during this maneuver is always having a reference in front of you, for instance, hangar or a trees, so you know that you're going right direction that you want to go. This is very interesting if we relay on the one that we've seen previously. In fact, this is the rapid transition. And what is the difference? You see already from the drawing that the helicopter will climb a little bit more from the ground, differently from the slow transition, and due to, of course, the effect transitional lift, but also you will like to be a little bit higher because you will need to be faster, and you will perform a quick stop. So you will need some space from the ground at the position in which you are in order to perform a safe quick stop. So you are here, you're increasing your speed with your collective, always act with the taxiway, and then you will manage your high from the ground with your collective, with your cyclic, and not with your collective. This is the difference with the quick transition. And then eventually, if you are too high, you put a little bit your cyclic forward, or if you are too low, you will pick a little bit your cyclic backward. So you will increase your high from the ground, and you will eventually stay among 10 feet from the ground, no more. And then at a certain point you decide to perform a quick stop. Always be careful to your tail, rotor tail. It will not touch the ground, so you have enough space to actually quick stop. So reduce your speed. Of course, when you reduce your speed, your nose will pitch up, and of course your tail will go down. So you know that, right? So what you do, you put your cyclic backward, you lower your collective, and you put right foot. Okay, and that is mostly the explanation of primary secondary effect. We have talked about that during the first short briefing. And then since you are reducing your speed and you are almost stopping the helicopter, you put a little bit of cyclic forward in order to regain some speed, but eventually you have lost your effect transitional left, so the helicopter is descending, and then you will raise your collective in order to avoid the helicopter touching the ground, staying in hovering situation, in hovering position, not touching the ground. Always when perform this kind of a maneuver, always having a reference in front of you in order to keep your helicopter, the nose of the helicopter acts with a taxiway. Key points is to be fluid with the flight controls and having references, exterior references. And the dangers is, well, you have to do all the security check, and you don't respect the limitation and also the wind of the day. So be sure that you are into the wind when you are you are performing a quick stop on the ground, and always check the wind direction to know the strength of the wind, the wind speed. So these are the kind of danger that in case which you have not checked very well your security check, you have not done your security check, or you haven't respect your limitation, you can be in danger. So avoid being this kind of situation. Quick stop. So we have seen already the quick stop, just a little bit more in detail. So quick stop, well, what you have to know, just a summary of what you have to know, that during a quick stop, due to the fact that the helicopters pitch up, well, it will increase the coning angle of your blades. As you can see, this is normal, is your rotor disc, and when you are actually doing performing a quick stop, the blades goes up, so the coning angle increase, and as such the blades will turn faster, and you will increase your vortex ring at the tip of the blade. So be careful with that as well. And this is a little bit the drawing, the action of the helicopter during a quick stop. So you see, You start from inside ground effect, you increase your speed, the helicopter eventually climbs a little bit from the ground. You take the decision to perform a quick stop. You increase a little bit more your altitude, your high from the ground with a cyclic, and then you perform your quick stop by doing the same action we have said before. You put your cyclic backward, you lower your collective, and you put right foot. The helicopter will pitch up, the tail will go down. Be careful not to touch the ground, and then eventually you will stop the helicopter. You will like, put a little bit of cyclic forward to move forward, and the fact that you have lost the effect transitional lift will require a little bit of power, so you will raise the collective as you can see here, and always try to keep the helicopter axed with the taxiway, and this is our socket, meaning that we are into the wind, okay? And always you have to keep having a reference, a serious reference. I repeat it, I stress this more, but it's very important. So this is ended up our short briefing about transition and quick stop. I hope I was clear. If you have any question or any suggestion, please feel free to leave comments, and I will try to answer to you. Bye bye.